So my name is Megan Daly, and I actually have a PhD in neuroscience, and I've been studying just obesity and metabolic disorders for almost about 20 years now. And the reason why I got into it was actually because I'm addicted to cake. So I call it the birthday cake syndrome, that when I was a kid, whenever I would feel sad, I would want to eat cake. And I think that that was a conditioned phenomenon because when I was a kid, I would go to birthday parties and everybody would be happy and there would always be cake. And so I think I learned the conditioned phenomenon that cake meant happiness. And I always wondered, well, why is that the case? Why do I always just want cake whenever I want to feel good? And so I started to get into behavioral neuroscience to look at the conditioning mechanisms behind feeding behavior. And since then have kind of continued on looking at even beyond the brain what's going on in feeding behavior as far as other organs within the body. We are going to talk about the gut-brain connection as it relates to obesity. And the objectives for this section are that we're going to understand the anatomy involved in the gut-brain connection. We're going to compare and contrast the functional differences between obese and lean individuals, and we're going to predict the outcome of obesity treatments that modify the gut-brain connection. All right, so what you see here is the gut and the brain. Very simple. But before we even start and go any further, we need to go ahead and define what we mean by the gut. And in this case, we mean the gastrointestinal tract, the stomach, the small and the large intestine. But what you can even see in this picture here is that the gut is located in the torso and the brain is located in the head. And so the way that we look at this is that one way in which the gut and the brain can be connected is through the vagus nerve. And the vagus nerve is just a collection of nerves that are both sensory and motor in nature. And they carry information to and from the gut through electrochemical impulses or action potentials, which are the typical form of communication utilized by neurons. And we know that the vagus nerve plays a role in both food intake and obesity because there's evidence that indicates that it plays a role in how much you eat in a given meal, as well as we've seen differences in vagal nerve activity in lean and obese individuals. And also, we've seen that there's differences in how lean and obese individuals respond to nutrients or hormones released after a meal within the gastrointestinal tract. And we think that these differences may be mediated by the vagus nerve. So first of all, let's start with the sensory nerves of the vagus. These are termed the visceral afferent nerves. And these receive information from the gut and send it to the brain. And they can actually receive both mechanical and chemical information. And the mechanical information is really easy to kind of understand. So when you eat a meal, the first thing that you feel is distension of your stomach and your intestine. Well, that distension stimulates the visceral afferent nerves to send a signal directly from the gut to the brain, to tell the brain about how much you ate. The other signal is chemical signals. So the visceral afferent nerves can actually sense the nutrients or the hormones or transmitters that are released when you eat, and then send the brain a signal, something about the nutrients that are within the gastrointestinal tract. So this is just a more detailed picture as to what's going on within the GI tract. So here this person's eating a hamburger, and we know that when you eat that the food is going to be digested into smaller and smaller particles. And these nutrients depicted in yellow in the stomach or the intestinal tract then have the ability to bind onto receptors on secretory cells lining the GI tract. And here in the picture, these receptors are depicted in green. So the nutrients can bind onto these receptors, which then can cause a secondary reaction within the secretory cells. And that secondary reaction can be the release of different transmitters or hormones, which then bind onto receptors on the visceral afferent nerves. And then these sensory nerves send information to the brain that tell the brain something about what you ate. So this, of course, is a picture form of what I just said, but here are the words. So what happens is that when you eat, the nutrients in the lumen of the GI tract can be detected by specialized epithelial cells that secrete transmitters and hormones. And some of them are listed here: serotonin, cholecystokinin, glucagon-like peptide 1, or peptide YY. And all of these known as satiety hormones because they're known to decrease food intake. The other part of the vagus is the motor component. And in this case, the motor component starts in the brain and then sends information to the gastrointestinal tract. And we know that these are parasympathetic in nature because they're responsible for the unconscious stimulation of the GI tract muscles, as well as the glands and the secretory cells of the GI tract. So what has been happening within the past few years and more recently is that treatments for obesity are coming out based on changing the vagus nerve, either stimulating it or ablating it. And so here, this is actually one of the treatments that have been utilized in obesity. This is the stimulation of the vagus. And in this case, what happens is that an electrical stimulation is applied to the vagus nerve, and it stimulates both the sensory and the motor component. And what could happen then is that a greater motor component could cause an increase in the muscle movement and secretions of the gastrointestinal tract, as well as a greater sensory nerve activation could cause your brain to think that there's more nutrients within the GI tract than there actually are. The second treatment for obesity has been looked at by ablating the vagus nerve or cutting the vagus nerve. And in this case, you're going to get cutting of both the sensory and the motor component so that there's no sensory or motor information going from the gut or the brain. The third treatment for obesity is where there's sensory denervation only. And in this case, this is done by application or ingestion of capsaicin. And capsaicin is that hot part of the chili peppers. Well, if you ingest that or you apply that directly to the GI tract, what happens is that you're going to denervate only the sensory nerves, leaving all the motor nerves intact. So the motor information from the brain to the gut is still doing its job, but the sensory information isn't working. So what you're going to do now is you're going to read a couple of the papers on the primary literature where researchers have gone through these 3 different treatments, and you can look at the data yourself and decide whether or not one of these treatments is better for obesity.